Okay, now let's come to real exam question for general solutions. So remember, with the first video it was just basics. So now in an exam they give you something like this. This is 3 sine x is equals to 2 tan x, but then we know tan x can be broken down to sine x over cos x, right? Now at this point here, let's get rid of the sine x. So we can get rid of sine x by multiplying both sides by sine x, 1 over sine x. Then if in here 1 over sine x, then here the sine x will cancel off with the sine x. We are only left with 3, and then the sine x here cancels off with that sine x. We are left with 2 over cos x, right? Then at this point, to make cos x the subject of the formula, can just do like this and swap this around. So this will become 3 cos x is equals to 2, and then we can divide both sides by 3, and then now we have cos x is equals to 2 over 3. So now we are at the stage where we want to calculate the reference angle. So this is cos and then 2 over 3. So inverse of cos 2 over 3. And then you just take your calculator and punch that. So we have cos, inverse of cos 2 over 3. And then that will give us 48,19. So let's just round off to 2 decimal places. So the x is 48,19 degrees. And then now let's mark this one as our reference angle. So what are we looking for? We come and check here. We are looking for the quadrant where cos is positive. So approaching our cast, we know cos is positive in the first and the fourth quadrant. So for the first quadrant, we have what? X is equals to the reference angle as it is 48.19 degrees. So it's 48.19 degrees plus k 360 degrees, where k is an element of integers. Then for the fourth quadrant, we know that in the fourth quadrant the reduction formula is 360 minus theta. Then we have x is equals to 360 minus 48.19 degrees plus k 360 degrees. Then let's subtract that. So it will give us x is equals to 311.81 degrees plus k 360 degrees, where k is an element of integers. So you have your general solutions for the first quadrant and the fourth quadrant. Nice. Another example we have, it says determine the general solution for sine x minus 30 degrees is equal to cos 2x. Now one thing that we know is we cannot do our general solution if we can see that here we don't have the same trig ratios, right? So here this is cos and the angles are also different. This is cos 2x and then this is x minus 30 degrees. So if the angles were the same, we can maybe form the tan type kind of general solution. But then here we can see the angles are not the same, and then also the trig ratios are not the same. So what can we do with this one? We know that there is a way to change cos to be the same as sine by doing what? By applying cofunctions. So this is sine x minus 30, and then we're just gonna write this cos 2x as sine 90 degrees minus 2x. So now we know that sine 90 minus 2x is the same as cos 2x, right? Because remember, when this reduces, so we know that sine 90 minus theta is the same as cos theta. We call this cofunctions, right? So these are part of our cofunctions. But then why do we do that? Because we want to work with the same trig ratio. Now that we have the same trig ratio, we can just cancel out the trig ratios, and then we are left with this. So x minus 30 degrees and then 90 minus 2x. Now the mistake that a lot of you make is that you want to solve at this point. Now the only thing that you do here is just to write here reference angle. So this is the only thing you want to do. You want to get rid of these trig ratios and then leave it like this. From here you don't do anything, you just write reference angle and then you start choosing your quadrants. So we can see that this is in the first quadrant because of the 90 degrees minus, so we know that represents the reduction formula of the first quadrant, and then we know all trig ratios are positive there. So in other words, we are looking for where sine is positive, right? So sine is positive in the first quadrant and also in the second quadrant. So let's check first quadrant. We have x minus 30 degrees and then is equals to 90 degrees minus 2x plus k 360. So we are working with sine. We know that the period is 360. Then at this point, this is where you now want to solve. So you take this negative 2 and then transpose it to the right hand side. So you have x plus 2x, and then you have this 90 here. You can take the 30 and then you say plus 30 degrees plus k 360 degrees. Right, then what will happen here? This is x plus 2x, it gives us 3x, and then 90 plus 30, that's 120 degrees plus k 360. Now at this point you want to divide everything by this 3. Remember, you only want x there, so this is x, and then what is 120 divided by 3? So that will give us 40 degrees. So we have 43 degrees plus k, and then what is 360 divided by 3? That's 120 degrees. So you can see that this 3x actually reduced the period to 120, right? Then k, element of integers. So for the second quadrant, you will say, in the second quadrant, the reduction formula is 180 degrees minus theta. So now you will say, you will take this one as it is, then it's x minus 30 degrees and is equals to 180 degrees minus the reference angle. So here let's start by saying minus the ref angle plus k 360 degrees. So now we will have x minus 30 degrees is equals to 180 degrees minus this expression, the reference angle. So minus 90 degrees minus 2x, right? Then plus k 360 degrees. So now let's solve here. We have x minus 30 degrees is equals to 180 minus 90, that's 90 degrees. And then what is negative times negative? That's positive 2x, and then we say plus k 360. Now at this point you want to transpose this 2x to this side here. So we have x minus 2x is equals to 90 degrees plus 30 degrees. So we took this negative 30 and then brought it here, then plus k 360. So what is x minus 2x? Negative x, and then here we have this 90 plus 30, which is 120 degrees, then plus k 360 degrees. But then remember, here we have this negative 1, so we want to divide everything by this negative 1 like that, and then this will become x, and then here we have negative 120 degrees. Then remember, this negative doesn't really affect this positive k 360, so we can just write this as plus k 360, or we can just indicate plus minus k 360 degrees, and then we say k is an element of integers. Okay, so let's look at this one. To determine the general solution, we are given this 2 sine x, and then cos x is equals to cos x. Then here right away we can just divide by cos x like this, both sides, and then the cos x and cos x here will cancel. So we are left with 2 sine x is equals to cos x divided by cos x is 1. And then remember, we want only one trig ratio to be the subject of the formula. So we have sine x is equals to 1 over 2. Now at this point we want to calculate the ref angle. So this is sine and then 1 over 2. So we know that sine of half is 30 degrees, so we have x is equals to 30 degrees, and then this becomes our reference angle. Right, now at this point you want to check, you are looking for where sine is positive. So consulting our cast diagram, where is sine positive? It is the first quadrant and the second quadrant. So we'll start by the first quadrant. We say first quadrant, this is x is equals to 30 degrees plus k 360 degrees, right? Then we'll just say k element of integers. Remember, first quadrant, you take it as it is. Then in the second quadrant, the reduction formula in the second quadrant is 180 minus theta. So we have x is equals to 180 degrees minus our reference angle of 30 degrees, and then plus k 360 degrees, right? So we have x 180 minus 30, it's 150 degrees, and then plus k 360 degrees, and we say k is an element of integers. Then you are done with your general solutions. Ra.